Hello, welcome to Upgrading the Engine Mid-Flight, how Google improves its web apps without downtime. I'm Ted Sander, this is Paul Rohde, and we're going to be your guides on this journey. So flashback, 2013, Google I/O. A developer is watching all the sessions from his computer. He's learning about Polymer, about Dart, about Angular, about removing jank from his web apps, about improving the render speed of his application, and he just gets really excited about all this cool new technology they can use. The speakers make it seem so easy and so powerful. It just excites him and gets him very excited again. So during his downtime, he starts using all this new technology, and it's easy and wonderful, and it just makes him love programming again, right? It's just fun to do, and everything just simple and powerful, and he can build great apps using all this technology. But every morning, he wakes up, gets in his car, and drives to work, sits down at his computer, and is just frustrated. He makes a line of code change, takes him about 15 to 20 minutes to see it on the screen. He's about 5 levels away from the DOM. He doesn't even remember what it looks like anymore. He's hardly touching HTML. It's in this other language that's being translated a couple times before it actually gets to the renderer. He can't use all the cool new tools in Chrome and everything else because the app's just huge and he can't even do anything. It's just so frustrating. He just doesn't want to deal with it. So he has this crazy idea, right? What if he could have that excellent environment that he has at home? What if he could bring it and actually do the same things at work? What if he could get all the power from all those cool technologies that he worked with and just make development fun again, even at work, right? So he goes to his coworker, and he tells him his crazy idea, and they start working through it. And there's just so much code. There's so much legacy code. They have all these tools that they can use with. The problem just seems impossible. It just seems so hard. They don't even know where to start. Where do you even begin on this journey, right? It just seems like it's unattainable. And that developer is me, right? And I don't work for some government contractor. I don't work for a bank or something like that or some other old school system. I work for Google, right? The people that developed all this cool new technology. It's not, even at Google we have these problems. We have these problems of these old systems and these older applications that we've made. We don't magically get all the new Polymer stuff just because we snapped our fingers and we invented it. It doesn't magically become into every single one of our apps, right? We still have to day-to-day deal with upgrading and making it happen and making all this new technology go into our apps. It's just like, and I'm sure many of you in the audience can relate, right? You're sitting there, you're learning about all this new technology, and you're going, there's no way I can use that at work, right? There's just so much work that would need to be done. I don't even know where to start. I don't even know where to begin, right? Or maybe perhaps you have the luxury of having a complete greenfield system. You can start everything from scratch, and you can do whatever you want, right? But how do you make sure that in 1 I/O, that in 3 IOs, that in 5 IOs, and 6 years down later, how can you ensure that you too can use all the new technology that's coming out then? What kind of practices can you do to make sure that happens? So our goal for today is to give you some of the challenges that we went through in trying to upgrade our apps and some of the strategies that we had so that we could make it happen, right? We'll give you some examples on how we did that, but the more important is the strategy and the tools that we tried to enforce to make sure that we could make this upgrade much more easier, more like a walk in a park and less like scaling a mountain, right?
Wow. I've never, ever had to deal with that ever.
Yeah, you're pretty lucky.
Yeah. You guys have all seen this happen if you've done development for any amount of time. You've seen small applications grow into large applications. You've seen these challenges as systems get larger, they strain the edges of what you can actually do. The technologies start to break down as your applications get bigger. And just maintaining code after a while slowly gets to the point where you just don't want to do it anymore. So today we're going to talk through, like Ted said, what we've gone through, some strategy we've been through, and we're going to cover it in 4 major areas. First, we're going to talk about large applications, and just any application. We're going to talk about how we break them apart into smaller pieces. We have huge applications, and lots of people work on them. So how do we take 100 engineers and distribute it across a single front end? So we'll talk about that. Second, we're going to talk about testing. Because if you're building a large front end or any large application, you want to make sure that it continues to work day after day. You may release it on day 1, and it may work. But how do you make sure that it continues to work on day 2, on day 3, and release number 5, 10, 15, all the way out through the life cycle of the application? So we're going to talk about testing and what we do, how we do it, what we found that's important. So we're going to talk about that. Third, we want to make the front-end engineers productive, right? Like Ted said, you want to take the development environment that you have at home, the ability to go and hack stuff up and build something really quickly, and then be able to take that to work. So we wanted to show you how to take that to work, what we've done to make front-end engineers productive, and the tools that we use to pick frameworks and tools that worked for us. Third, or fourth, and finally, we're going to tie this all together. We ended up with Dart. But we're going to talk about how the language takes everything that we're going to talk about in the first 3 sections and how it ties it all together. And then we're going to wrap it up, and then we'll be able to end.
So this is great, Paul. I mean, but how in the world are we ever going to start? We have hundreds of engineers, millions of lines of code. It's just this huge, large app. Like, how are we ever going to begin to start porting this over to the new language?
It's a great question. We have huge front ends at Google. These are not small, little blog web pages. We have applications that have over 1 million lines of front end code. That's a lot. Not only that, we have hundreds of engineers working on them. Now, you'll see these strains regardless of the size of the project or the number of people you have working on them, but just imagine how hard it is to deal with a code base of that size and have that many engineers. Now take that and release your front end every single week. Think about that for a second. Like that's a hard problem to deal with. As applications get bigger, you have to avoid this place where your applications can just start imploding on themselves. You want to avoid this. So we have a strategy. We want to divide and conquer our apps. This is kind of what our application looked like. You have one big front end, one JavaScript binary that has lots of little sub-pieces. And this is the problem, right? Because if you have something like this where every piece talks to different parts of the app, it's hard to take a single piece, pull it out, and work on it in isolation. So what do? We had to do something for this because we needed to be able to have all these engineers be productive and actually build things. So we took it and we split it up. If the slides will actually go. All right. So in this case, and this is not the only way we can do it, but in our case, we built a message bus. Very small, very simple. It was just one little piece of JavaScript that let us pass messages between other applications in the page. Now, I guess a little context is the front end that we're talking about is all a single application. It's a single page. But we broke it up into smaller sub-apps. And each app talks to the other app through this message bus. What this allowed us to do, because we had separate JavaScript binaries, is we can now replace any single application individually. A team of developers can work on one single application without having to deal with a lot of the interactions of the other pieces. It lets us version things. It lets teams release things on different days. How many of you have sat back and had to everybody coordinate for the same release? Having 200 engineers or even 100 engineers or even 10, just getting them all to get their code in so that you can actually release something is really hard. So being able to have smaller sub-teams that release independently and develop their own features and it can all work together in one cohesive way is really, really powerful. So it's this idea of one simple interface. In our case, this was really, really powerful. Having a single point of failure and a single place where everything coordinates was really powerful. Now, globals are generally bad, so you don't want to do this all the time. But in this case, it enabled us to do so many other things that were really valuable. So that's that. And my slides are being wonderful. Here's an example. We got some concrete code examples. Just where you have a global context, which has a message bus in it, and a simple send and listen. In our case, we used just JavaScript maps with string variables, and then just pass them back and forth. Very simple, all done by convention. But But again, it was something that was very powerful and enabled us to do a lot of new things. So this is cool. So you can take your app and you can build it and you can break it apart into small pieces. And this is good regardless of the application that you're building. But if you do this, all of a sudden, your applications, they have a lot of code that you need to share. So Ted, how are we going to deal with this problem? We want to be able to share all this code, but we don't want to duplicate it and write it all over again.
Yeah, that's a good question. I mean, you have all these different apps written in different languages. There's configurations between them. There's the APIs that all need to talk similarly, right? How in the world are we going to make this happen across all these different apps? Well, the strategy is to always have a single source of truth. And what do I mean by that? Well, you don't want to have to hand write two different things, right? You don't want to have your API handwritten in Dart and then handwritten in JavaScript, right? Because then what's going to happen is somebody's going to change one and then forget to change the other, and you're going to have this hidden bug that you're never going to find, right? So, and this pattern comes up a lot for the single source of truth, for configurations, for APIs, stuff like that. So let's take an example. AdWords API. As you can imagine, we want to use as many people as possible to use AdWords API as they would like, right? It's 100,000 lines of code, and this is just for interfaces, right? I'm not talking about the implementation of the AdWords API at all, just the API itself, right? And there's 34 services that people can use. And we ourselves use this service. We dog food our own API, right? So the APIs that developers are using are the APIs that we use ourselves. Now, we want to allow any developer to be able to write using this API as possible, right? It makes Google money. AdWords API makes us money. So any language that a developer wants to use, we want to support if we can. So there's 6 total client languages that we have. And we'd be crazy to write 100,000 lines of code 6 times, right? It's just not going to happen. So how do we do this? Well, we generate our API. Right? We have one consistent API, and we generate everything else from that in all the other languages. So having a single source of truth. So let's do a very simple example for a configuration. At Google, we love proto-buffers. We use them all over the place, right? So we have a very simple proto-buffer. It's a rainbow that has the number of colors that it could have, right? From this, we can generate the Java code. Right, very simply, has its getters and setters. And we can generate the Dart code, right? And protobufs support some other languages too. So we have the one single source of truth, which is the protobuf. And from that, we can generate the language-independent versions that we need, right? And you can generate this using the Dart Proto-C plugin. OK, that's great. You could use protobufs for configuration. You could use YAML for configuration, anything that supports multiple languages. And you can get along fine there, right? But what about your API? Well, you could use protobufs. You could use JSON. You could also use Google Cloud Endpoints. It supports many different languages. Or you could use Thrift or similar system to do this. So here's a very simple example. Let's say we want to send those rainbow objects to our server. Luckily for us, in Dart, it's really, really easy. You have a URL to the endpoint of your service, and then you can actually just post on a request the JSON. And protobuffers actually have JSON support built in. You could do it in binary, but we found out that the JSON was way faster than binary, so that's why we chose that direction.
Cool. So we can generate stuff. We can do things. We can break apart our application. But that doesn't really mean anything unless we can actually make sure it still works, right? I mean, you want it to be able to work one day, the next day, and the day after. And we've seen some pretty bad examples of code that failed, that was not very well tested, right? I think that there should be ways that we should be able to ensure that our code continues to work and that it actually works the way you intend it to, which is really important. So how are we going to do that?
Yeah, so this problem even goes farther than that, right? The landscape that we live in, everything's moving really, really fast. The Angular team, we use Angular. Angular's making changes to improve their system every single day, every single week, right? Polymer is actually a moving target. A lot of these are in spec, but they change things and make things different every single day, every single week. So you have the libraries. You have the whole earth is shaking under you and changing. How do you make sure that all that's working too, right? It's a big problem. And the only way that we've had to solve this was test coverage. Test coverage is key. So what do I mean by test coverage? That means how much of your production code is covered by tests, right? How much unit tests, how many integration tests, how many UI tests do you have? Luckily, all the languages we chose and stuff like that make it really easy to do. And at Google, we have an idea, and that is the idea of test sizes, right? Not all tests are created equally, right? So there's 3 different versions that we have at Google, and we like to categorize them as this. And one is small tests. Small tests run very, very quickly, less than 100 milliseconds. Mostly they're unit tests, right, and that kind of level. And we'll talk a little bit about what that is. Then we have medium tests. Medium tests execute in about a second. And these are UI tests, integration tests, things that still run pretty quickly, but they're a little bit more complex. Then we have large tests, right? These things that can take up to 15 minutes. They're insane. We have full stack tests. Maybe they're performance tests. And largely, they're automated tests. So what are these? These are the web browser is actually running to input the code on your web page, right? So you actually see the text being filled out. You see the select boxes being chosen. It makes you feel really good because your web page is actually working, right? And that's the way the test is working. So it gives you like a security blanket. But they're so long to run, they're actually not that good, right? So here's what your desired test coverage you want it to look like. You want to have about 10% covered by large tests. You don't want to use them too often. You want to maybe have a smoke test or a stress test, something like that, just to make sure everything's still working. Medium tests, those are your UI tests. UIs usually you have a little bit more of these because they take a little bit longer to run because you need a browser and interact with DOM. And then you have your small tests. So medium tests, you want about 50% coverage, and small tests, you want about 70% coverage. And if you're going to have more coverage on small tests, then that's good, right? Small tests are just the unit tests, like I said. But this was our problem. This is what our test coverage looked like, right? we had all of these large tests. Our tests sometimes took hours to run, right, on our application. Because we felt really good with these automated tests. We could see that everything was working, right? It was actually running our application fully. And it made us feel really good inside to see it working. But it made the tests what we call flaky. And what does flaky mean? Flaky means that you had the test aired out, and the test didn't work, it failed. But really, if you run it again, it's going to pass, right? There's nothing to make that test fail in the actual code. It's just because it took too long to run, it timed out, something like that, right? And then we had this problem with medium tests. Medium tests, UI tests got a bad rap. They were hard to write. There was some problems with them, and everybody's like, "Oh, I don't want to write them. I'll just write a automated test instead," right? And it created this huge problem that we couldn't rely on our tests. They would fail all the time for no reason, and you're just like, "Oh, well, the build's red, but that's probably just because it's going to work next time. I won't worry about it," right? So, how did we fix this? Well, luckily, the tools that we decided to use make it really easy, and there's some philosophy changes too. So one thing is quickly, what does a unit test look like in Dart? Well, it's really easy to write. You want to keep it really simple. You want to have one action, and for that one action, you want to make sure that it has the expected value that you expect. You want to try to only test very little things if you can. Don't have a unit test that tries to cover like every single exception that you want in that one unit test. Why? Because the next developer that comes along, he won't know if that it's failing because one specific thing or if it's failing 3/4 because of something specific. If you make it really specific, then they can look at the title and hopefully go like, "Oh, I don't even need to look at the code. I can figure out exactly why this is breaking." So another problem that we had was asynchronous testing. Asynchronous testing was actually really hard in our old system. But luckily, Dart makes it a little easier, but Angular makes it very easy. And I'll even use asynchronous testing using Dart Angular without needing Angular at all, right? And so what do I mean by this? Well, Angular turns async testing into synchronous testing, which is awesome. They like to call it time travel. They actually control the clock. So if we look at our little example, there's a future in there. And that future is not going to be run right away when it's declared, right? It's going to be run later at some time. In the Dart regular unit test, you just kind of say that there'll be a future later, and you can hook onto it, and it will eventually allow you to test it. But using Angular, as you can see, at first it's a false value, but then you give up your rendering loop, and you say, oh, please do whatever you need to do. Please leap forward into time. And then the futures actually run, and we can actually make sure that the value is what we expect, turning asynchronous testing into synchronous testing. Super powerful, made it less flaky. OK, UI tests. Here's another problem. We didn't like writing UI tests. They were hard for us. Again, Angular to the rescue. So there's a way to easily have testbed, which sets up your Angular components and directives. And then you can actually pull out the Angular object itself and then play with the Angular object, rather than using DOM manipulation or sending DOM events somewhere, doing something kind of crazy like that. You can actually test the higher level object, which makes it very easy. But yet at the same time, you have the HTML. So you can quickly make a little snippet of HTML and start testing things nicely. OK, so we have this problem at Google that since all these other teams are working on completely separate things, how can you make sure that the team next to you didn't change their interface or make something that's going to break you? And I have a great example for this. And that's in 1999, there was this project, and it was called the Mars Orbital. And the Mars Orbital gave out the project to a couple different government contractors, right? And the systems in separation worked great, right? Each government contractor tested it, and it worked awesome. But it turned out one government contractor was using English units. They used feet. And the other government contractor decided to use metric, like the rest of the world does. But NASA doesn't use metric, by the way. They use English metric. So when this was actually going up to Mars, when it was about to orbit Mars, the systems freaked out, because one was telling it was the feet value, and the other one was expecting metric. So it thought it was going to crash land into Mars, right? So it bailed. It's like, I'm out of here. Like, I've got to make sure this doesn't happen. I don't want to crash land into Mars. And it actually shot right past it. $100 million mistake that could have been solved with integration testing. And this happens for us too, right? You have maybe a library that you don't quite rely on, or it's a little sketchy, but you need to use it. Maybe you're worried about them changing their interface, something like that. And you want to test the integration between your pieces, right? Or for us, we have those integration points. We split up all the apps. We need to make sure that if somebody changes one interface, that it's not going to break some other application, right? And so here's a really simple interface, simple way to test two widgets, right? I just came from Brazil. And one of the problems that I had there is every time I tried to enter my information into like an airline form or whatever it might be, Brazil actually has different telephone input, right? So here's an example of something where you could have one which is the country selector, which allows you to select which country you're from, and the other is the telephone input, right? So when you choose Brazil, the telephone input should change and should give you the right input for Brazil. If you have the US, then it should be the right input for the US. You don't need to fully test each widget in this test. You just want to make sure that that interaction between the two is working in the way that you expect. OK, and lastly, we are always testing at Google. And luckily, it's not QA testing, because I wouldn't get any work done, right? It's not me clicking buttons, because that wouldn't be fun. And honestly, I probably wouldn't find too many bugs. But we are always testing. Our cloud is always testing our code. So what do I mean by this? Well, every time before we check in any code, we make sure it works on our code base. Anytime any other team checks into code, like Angular or Polymer, we make sure that that code works, right? And we've got our own tools to do this, but you too can do something like this, right? And here's an example of it. It's Travis. Travis and Jenkins are two good tools that you could use. And the Angular Dart project actually uses it externally for GitHub. So you could check their page to make sure that they're working correctly and make sure everything works well there. So Paul, like I said before, we had this problem of there's so much DOM. We had this div soup, and writing front ends was hard. I was like 5 levels above the DOM, I didn't even know what it looked like anymore. Like,
Yeah.
how are we going to fix that problem?
Yeah, it's a hard problem. Man, one of the time when I first started, our front ends, they would take 15 to 20 minutes to compile. So I would go and I would sit down and I'd make a change, and then I'd go play Candy Crush for a little while and then wait for my code to compile, and then I would go back and actually see what actually happened. And this is terrible. Waiting that long for something to compile, like, there's just no way that that's going to make me productive. Some applications were a little bit worse, some were a little bit better, but having a compile time that just took that long to actually see a change, your mind just does this mental context switch, and you have to go back, you have to remember what you were doing, what you changed, why you changed it. And it also means you end up coding really badly. You end up sitting down and writing 120 lines of code to because you don't want to wait for the compile, and you just hit go, and you're like, I hope that was right. So this is one problem. So as we started looking forward and said, OK, what do we want to do next? This was one of the problems we wanted to address. We wanted front-end developers to be productive, to make a change and instantly see it happen. So that was one problem. The other problem is we got really far away from the DOM. Now, back about 5 years ago or so, this was really important. Like, how many of you remember seeing polyfills make rounded corners on buttons and things, right? Or how many times did you try to align stuff with CSS and it didn't work, but it worked in one browser and then another browser didn't work? So we got farther away from the DOM for good reason, because the browsers weren't able to be consistent. So now the browsers are tested. Now they all work fairly well, and alignment usually works most of the way you expect it to. But I still had this problem, right? Because I was using frameworks that was farther away from the DOM, I could build something in a prototype in a couple of days. I'm usually pretty good with CSS and pretty good with HTML. And I could throw something together and make it all work and function basically the way that I wanted it to. But it's still, then I would take that prototype, and then I wanted to actually build it in production code. Now, obviously, there's going to be some amount of overhead to do this because there's all the edge cases you have to account for and things like that. But if it took me 2 days to build it, it would take me 2 weeks to actually, or even longer, or even a month, to actually build a final version of whatever I wanted to build. And this was just killed my joy of actually building stuff. So we wanted to, as we went forward and we wanted to do something different, we started looking at what can we do to get closer to the DOM, and what can we do to solve some of these problems. So the strategy was, we don't want to fight the HTML. HTML's gotten a lot better. You've gotten a lot closer to the DOM. We've seen all the cool stuff that Polymer's been doing. You want to get closer to the DOM so that when you're writing applications, you're not writing this big, vague, abstract sense of I need a thing. You want to extend it. You want to make the DOM more powerful. So we picked up Angular Dart, which is, you guys should have all heard about Angular at this point in time. But Angular has 2 flavors now. They've got a Dart flavor and a JS flavor. We'll talk about Dart in the last section, but I want to talk about Angular really quick. It has a lot of the very same underlying constructs as Polymer, and it gives you behaviors. This idea that you want very simple things that you can then bind into your model. This is really powerful because it gets you close to the HTML. You can write your page, and then you can add little behaviors to the HTML that you've already written. This is really useful because we'd have prototypers that would go, we'd have a mock that would be built up, hey, we want to build this. And then they come in and someone would build the HTML, and then I'm now able as an engineer to take that and just extend it and fill in all the missing pieces. So what does it look like to have behaviors? Angular has some very simple things like ng-repeat. They're very simple. It does one thing. It takes a piece of DOM and it stamps it out over and over again. And it lets you have a model that is discrete. Now, this is really useful when you're trying to test things, when you're trying to build business logic, and you want to make sure that your code actually does what you expect it to do without adding timers, without adding DOM manipulation, without adding all this extra fluff to your code. All you want to do is you want to say, I have a list of people, and I want to add a new person. You don't want to say, I want to keep a mapping of person to DOM element, and then when I add it, I create a new one, and then I append it, and I append it in the right place. Did I not append it in the right place? Now I want to remove this one, so now I have to go to the DOM and have to remove it. You just want to have a list of people, and you want to say add and remove. And Angular lets you do this. The other example I give is ngIf, but only because with these 2 behaviors, you can now compose things together. This is what becomes really, really powerful, is this idea that you have these simple behaviors like gears that you can then take and you can put together. And you can compose repeats with ifs, and you can build a huge, very functional UI in a very short amount of time that's very solid. And that's what you wanted, and this is why, part of the reason why we picked this. This whole idea that you want simple things that you can then compose together. A gear is very, very simple, but a clock is easy. Now, when you're building an application, you need lots and lots of simple pieces. And it's important to realize the difference between simple and easy. Simple, you can compose together very easily without effort. You can't reduce it any farther. With ng-repeat, for instance, you can't take away anything from the actual behavior and make it into, if you took it away, it wouldn't actually be a repeat anymore. Same thing with if. It's about as simple as you can possibly make it. A clock, on the other hand, is great. It's very self-contained, and it has a really good usage. But it's one of those things where it's the final state of something. You can't take a clock and compose it with another clock. You have to rip it apart and take all the gears out, and then you can build a dual clock. But you have to, there's a lot of work involved in ripping it apart and putting it back together. It may be easy because it tells time and you can wind it and change it, but it's not simple. And it's an important distinction. They're both good, but they just have different purposes. So you guys have seen lots of Polymer component stuff today. And Angular is built on the same foundation. It uses the same underlying technologies. It uses Shadow DOM, it uses the web component spec, and it uses all these same underlying technologies. It just does it a little bit differently. Regardless of what technology you use, you want to have a story for building components to isolate things in your page. Especially when you start talking about CSS. CSS is the last remaining global variable on your web pages. You want to get rid of that so that you can actually have object-oriented programming and apply it to your web pages and not just as this global thing that styles everything. So this is really useful, and we've seen this be really useful. This is an example of what it looks like if you opened up the inspector. It's basically a bunch of elements that exist behind the actual element, and it lets you scope things. So your style element doesn't leak outwards, it doesn't leak down. And it prevents this mess when you build really big applications. It's really easy for developers to write styles that step on each other. I don't know how many of you have ever written web pages, but have you ever seen somebody write a paragraph tag with a red important tag and try to figure out where that actually came from? It's really hard. And so this actually gives you real scoping that's just much better. And that's really powerful.
So that's great. I mean, we seem to have a story figured out to make it better for developers to write HTML and be closer to what the actual designers are making and that kind of stuff. But how in the world are we going to make sure that this works for 100 engineers, 1 million lines of code? How are we going to make sure it's going to scale every single time we use it and that 5 years down the road we're not deciding to do something else?
Yeah, that's a good question. I mean, like you said, we have lots and lots of engineers. We have huge code bases. And we want to be able to build these huge front ends, and we want to build them quickly. And then once we build them, we want to be able to change them, because that's how you build a business. You build something, you take it, you iterate on it. So we picked up on Dart. We loved a lot of things about the language itself, but mostly it was able to take what we have, and we were able to tie it into one cohesive tool set. So instead of having a mishmash of one thing, another thing, 2 libraries here, 1 library here, a different language underneath, JavaScript, we wanted to build a stack that we could have a very clean, well-defined way to build front ends that worked for a lot of different people. And we wanted to have a cohesive story of how you can build a front end quickly and how you can continue to scale that from 1 or 2 engineers all the way up to 100 to 200 to 300. So we wanted these tools, and we wanted to be able to do this. And we picked up on Dart, and I'll explain in just a second. So like I said, Dart has a lot of different things about it. Its batteries included. It has all the different pieces that we needed. And I'll show you why. The first thing that we wanted is we wanted it to be fast. And this was a big, huge selling point for us. We wanted our front ends to run just as fast as JavaScript, right? Because if it wasn't going to be fast enough, why not just do JavaScript, right? Because we have to run it in JavaScript anyways. So even Dart, it compiles the JS, and it runs just as fast as JS. It's fast. And it also has a bunch of other things that we liked about it, too. If it will go. Anyways. So Dart is fast. And my slides will eventually keep up. Yes, there we go. And a lot of benchmarks, specifically, you can go on the Dart webpage and you can go look these up. There's a bunch of benchmarks, and what we really cared about was Dart to JS. Because even though Chrome may be coming along and iterating really fast, we still knew that we had to run as JavaScript, at least for a good amount of time. And a lot of browsers were not ever going to adopt any sort of engine other than JavaScript. So we wanted, that was a core requirement, was that it had to be just as fast as JavaScript. And it is. And it gives us a lot of other things as well, beyond just JavaScript. The biggest one is types. I don't know how many of you tried to grep a file to replace a string in JavaScript, but you have no idea if it actually worked or not. We wanted to be able to do refactoring. We have large teams of people, and you want your code to be readable, but you also want it to be refactorable. You want to be able to take a class, remove it, change it, modify it, rename things, and know that when you change it, it's going to change in all the places you actually care about. If you don't, then you end up in this soup of like trying to figure out exactly why this method exists in sometimes and not other times. And we didn't want that. And so Dart gives us types. It also makes it so it can optimize the JS faster. And we can do that with Closure in JavaScript too, but just having built-in support was really nice. As an example, not only does it give you types, but it's still dynamic. It still lets you do all those JavaScripty things. As an example here, like we have, this is the same method with types and without types. So you still get all the flexibility that you have with JavaScript, but by default, you want to put in types, but you don't have to if you don't need to. Or if you have a case where you really don't want to and you want to jump into more JavaScripty type things. And this is really important as we build web front ends, because a lot of times you run into these cases where you want to build things either statically and dynamically. So Dart gave us to this. Dart gave this to us. Next, Dart gave us a package manager. It's really hard to manage dependencies if you don't have a good system for managing it. Now, you might have a good system, but if you don't have a consistent system that's shared between a whole bunch of different things, that's really hard to deal with. Do you pick require.js? Do you pick like a whole bunch of different package managers? Do you use Node? Do you use what do you use to manage code dependencies, right? So Dart, again, with this whole theme of there's batteries included, it gives you a package manager that can let you manage all the dependencies of your code. And this is really, really powerful, because then you don't have to fight over which package manager you're actually using. And if you use a different library that happens to use something different, you're not restricted because of that. So that was really important for us. I have an example up here of what it actually looks like. The pubspec.yaml is basically just a configuration file. You don't have to pay too much attention to it. But it lets you specify the dependencies. It's all pulled through pub. It's got a central ecosystem. And you can get new ones, either pub get, and pub upgrade lets you upgrade existing dependencies and things like that. But it's just a simple dependency management system, but it's baked into the language, and it's part of the whole ecosystem that comes with it. We picked Dart not just because of the language, but because of the ecosystem. So that's about all we got for you guys today. Hopefully that was at least useful to at least see some of what we do at Google and see what it's like for engineers to come up and actually speak and share a little bit of what we do every day. I'm Paul Rohde. This is Ted Sanders. We'll be around a little bit to answer questions if you want to come up to the stage, and we'll talk to you later. But that's all we got for you guys. Thank you.